Welcome to the NestGen Xpress, sponsored by Flight Now. My name is Jason Sansucci, your host, and I am honored to be here today for our next guest. We are here with the co-founder and CTO of Elsight, Rohit Kashi. Rohit, welcome to the show.
Thank you for having me.
Oh,
Thank you for having me.
you are so welcome. I'm really glad that you are here. I just have a few sort of rapid-fire questions for you. Just love to hear your insights and approach to what we're talking about. So when it comes to secure drone network operation centers for BVLOS ops, do you think there should be a secret handshake or a special password to enter the control room? Or is there more like a high-tech fortress with biometric scanners and retina displays?
So this is what nice about looking at this as like a drone network operation center, but we're not changing the concept of security. We're not changing the concept of control center. But the whole idea is to not inventing the wheel as much as possible. But let's take the concept that we already know or they're familiar with. It's the SD-WAN concepts of having control center that has a lot of this kind of missions or different abilities to control a lot of different stuff. This is nothing new. But now let's take the same approach and apply it on controlling drones. So it makes our job much simpler because what we need to do is just to make sure that the drones are well connected to the control center, are well connected, well secured. It has this reliable connectivity and just connected to the same systems that currently run existing control centers. So by having this kind of security, the basic idea is to make sure that the personnel are secured, and you want to make sure that you have zero trust kind of technologies, which means that you don't need to trust on people in the network, just computers at the part of the network, but you want to make sure that each application is authenticated. We want to make sure that each user is authenticated. And this one is like existing technology. And by having this bridge that integrates this side with a VPN that is able to communicate with all the drones, you have it done.
Nice. So, can I recommend a fist bump? Like just a fist bump to enter. Just boom. All right, we're secure. Fist bump security. I like it. Okay. It's already trademarked. Website's already purchased. Okay. So obviously BVLOS operations come with their own unique set of challenges.
Yeah.
So you got to maintain reliable communication. You have to ensure safe navigation. You have to comply with the regulatory requirements. So can you share a few practical strategies to overcome these common challenges and successfully conduct BVLOS missions?
Yeah. Well, we're talking about BVLOS connectivity. Then we need to understand that it goes first beyond the immediate interpretation of beyond the pilot's visual line of sight or the radar line of sight, but it all goes to how from this control center I'm able to connect to multiple drones at the same time, having one pilot or supervisor that connects to all of them at the same time. But then again, how do I create this connection, reliable connection with the drone without having this point-to-point RF link, without having these people, the person that's working with a remote control? And it means that you need to work with existing infrastructure such as LTE, such as 5G, maybe satellite in some other places. But there's a lot of different tests that were done also from Ericsson and Qualcomm and Verizon with the FAA about how communication works. LTE works for drone, and basically what you see is that they're using the side lobes from the cellular towers. So having a single modem will just repeatedly lose the connection. So in order to do this, in order to have a reliable connectivity, what you need to have is what we call path redundancy, which means that at the same time you're connected to multiple different paths, different towers, different bands, different technologies, but at the same time you also want to have MNO redundancy. So you're connected at the same time to AT&T, T-Mobile, Verizon, US Cellular, maybe 5G, LTE, different bands. So you're not relying on a single MNO, a single carrier. So it's good for redundancy, it's good for better coverage for a signal, for having better quality of your link, better signal, better latency. And when we're talking about these different paths, then you need to set also the different the different, I would say, fail-safes. So if there's no cellular at all, you can start using a satellite link.
Okay.
So these are all parts of the same best practices that we encourage also with our Halo, that we provide 4 concurrent LTE links, or LTE and 5G, with the ability to automatically use satellite if none of it is available, or also to combine it with a point-to-point RFI. Part of this, for example, is one of our US patents for prioritizing C2 over video with drones with multiple paths. And it's also one of the things that you want to have, because if you're in a place with congested network, we want to make sure that you use this resource for transmitting the most important traffic, which is the C2, and not to waste it on video, for example.
That totally makes sense. So Halo, right here. So this is powered by 6th Sense technology. So I can't help to think of the movie The Sixth Sense starring Bruce Willis. So could we expect any sort of eerie or supernatural surprises when using this technology in BVLOS operations?
Yeah, you're not the first one to ask this, but well, we do detect dead links.
I can see dead links. I like it. No, I like it. I like it.
I would say even when we're talking about this kind of, I'll try to answer it even seriously. When we're talking about detecting the links, then it's important to understand that the Sixth Sense, what the main thing of it is to understand. It's like, we call it a little bit more like a spider sense. It's like to sense what could you do with the network before you start even to use it. So it works on either the kind of a flight recording that you can do and record the RF status, but then during the flight, we're starting to transmit the data through your links, but we have also a feedback link. So we're detecting what is the latency status, what's the congestion levels, what is the packet loss levels, and this way in real time, we're detecting problems in the links, and as well detecting dead links, and you want to know if they're dead.
That makes a lot of sense. Absolutely, and I appreciate the serious answer to a funny question. So, as BVLOS operations continue to evolve, what cutting-edge developments in connectivity can we anticipate over the next few years, and how will these advancements transform the way that drone operators approach and manage BVLOS missions?
Wow, that's a lot.
It is a lot.
I'll give you some examples.
I love examples.
I don't know if you've heard about, there's something that is relatively new right now in the industry, specifically on the cellular technology, and it started from the 3GPP. That's the standardization for the LTE, for example, and the 5G. And it's the ability to use a cellular tower, let's call it, a cell, that is not on the terrestrial ground, but it's on a satellite. So there are really the first kind of tests they're doing with all different partners. And think of what it means. It means that if you're taking a drone and to go, for example, in the middle of the ocean, like either ship to shore or between islands, or going in between different communities with you have just deserted area in between, we don't have terrestrial cellular,
Right.
but you still have a cellular tower on the satellite. So you use the same equipment with the same SIM card, for example, but you can use a satellite. So it's really cool. Another thing, when we're talking about this kind of new technologies in the cellular world, then it goes to 5G, and what you can do with 5G beyond just the, I would say, the marketing stuff, just high bandwidth, you can also have priority on the network. So think of some place that it's very congested. You have a lot of people there, but the drone is now that using 5G can get its own slice. It's called network slicing. By that, it has its own quality of service in the network, something that you can't do with LTE. Or for example, if you want to use edge computing, and instead of taking this data and offload it to a remote server, you can just have your AI computing, for example, on a local site on the 5G, and get the answer in much real-time response. So it's all kinds of these new abilities that comes from the cellular technology, like location services or edge replication services, that you're starting to see that we're looking at the cell technology more than just the signal or the connectivity, but a lot of additional things, additional services that we can offer to drone industry that is beyond just the connectivity itself.
That is a great answer, and that makes a lot of sense. So you'd mentioned 4G LTE technology. So when it comes to that particular drone connectivity on that service, so we're all familiar with the Verizon, can you hear me now? Can you hear me now? The tagline from the iconic cell phone commercial. So in the drone world, do you think that we're going to have our own version, like, can you fly me now? And as they zip through the sky, maintaining communication? And if so, how do they troubleshoot when they inevitably hit, I guess, a dead zone or a dead link? How will they do that?
So this is the interesting part, because we split it to the, I would say, the proactive and reactive approaches. When the drone is now in the middle of the mission, right, and in real time it needs to understand how to use all the different links, then the idea here is really to detect what is considered a good link, or who is a better one, I would say.
Sure.
Because it goes like well, there's another phrase, but there is no bad link, right? Sometimes you'll have like a link with 10 megabit per second, but 5% packet loss, or another link with 2 megabit per second, but with it's flawless and with low latency. So who's better? Well, so it's based on the mission, based on what you need to do.
Makes sense.
But the whole idea is to understand what is good for the actual data that you want to transmit, for video or for C2. So with C2, for example, you want to duplicate it to all different paths. With video, you don't want to add congestion.
Right.
So you want to have separate kind of applications, and you want to detect what is the real-time usage of the links. And this is what we do. We detect in real time the reliability of the links and how can we use it in the ideal place, I would say. But there's the proactive. And in the proactive method, you don't need to wait for a certain problem to occur in order to fix it. But if you have this kind of a RF recording that we have, and you already map your area, and you already, in the pre-planning, in the pre-flight planning, you already know what are the places that have the best statistical chance of having good connectivity,
Sure.
or the worst ones, and then you can avoid places that you might have issues with the signal, and go to places and just plan your route in such way that you know there's a better connectivity based on all the measurements, based on all the criteria, with all the SIM cards that we have, and with all the recordings that we already did. That's a great heuristics to understand if you're going to have a successful mission.
This has been absolutely amazing, and I'm not surprised at all that you were able to win this award, the ABSI Excellence Award 2023, second place winner, L-Site Halo. Amazing.
Thank you.
Congratulations so much. This is very exciting. And to all of you watching, this has been an exciting interview with Rohit Kashi from L-Site. This has been really, really fun. Thank you so much for playing along. This has been really great.
The fist.
Definitely. Oh, the fist. Oh, all right. That's the secret entry. Fantastic. So thank you all so much. This has been a lot of fun. We hope to see you all on the next episode. Bye now.
Hi.